What if I told you that the reason we haven't found any aliens isn't because space is empty, but because it's a cosmic graveyard? And what if I told you that right now, at this very moment, we might be living through the exact same extinction event that killed every advanced civilization that came before us? I'm going to walk you through one of the most terrifying solutions to the Fermi Paradox, a solution so unsettling that most mainstream scientists refuse to acknowledge it. But before we dive into the abyss, I need to know, where are you watching this from right now? Comment down below and tell me your country and what time you're listening to this. I genuinely want to know who's hearing this message. And before we continue, please hit that subscribe button. Not because I'm asking you to support the channel, but because what you're about to learn will fundamentally change how you see reality, and you'll want to come back for more conversations like this. This isn't just entertainment. This is a wake-up call. The Fermi Paradox sounds simple. If the universe is so vast, containing an estimated 2 septillion stars, why haven't we detected even a single alien civilization? Enrico Fermi asked this question in 1950, and 74 years later, we still don't have an answer. But what if the answer is far worse than silence? Stay with me. Let me establish what we're actually dealing with here. In 1950, physicist Enrico Fermi sat down with 3 colleagues at Los Alamos Laboratory, and during a casual lunch conversation, he posed a question that would echo through decades of scientific inquiry. Where is everybody? Think of it like this. Imagine you're at a massive, never-ending party. The venue has infinitely many rooms, each containing potentially thousands of guests. You'd expect to hear noise, laughter, conversations bleeding through the walls, but instead, complete silence. That's our situation with the universe. The numbers alone are staggering. Our galaxy, the Milky Way, contains between 100 and 400 billion stars. Recent Kepler Space Telescope data suggests that roughly 40% of Sun-like stars have Earth-like planets in their habitable zones. Astronomer Carl Sagan and his colleague Drake developed what's known as the Drake equation in 1961, which attempts to estimate the number of communicative civilizations in our galaxy. Even using conservative estimates, the Drake equation suggests there should be thousands, potentially millions of advanced civilizations just in our galaxy alone. Here's what will blow your mind. If intelligent life emerged on even 1 planet per billion stars, we'd still have roughly 2 billion advanced civilizations in the observable universe. Yet we've heard nothing, not a whisper, not a single radio signal that couldn't be explained by natural phenomena. So what explains this cosmic silence? For decades, scientists proposed what they called solutions to the Fermi Paradox. The most comforting solution was the rare Earth hypothesis, proposed by Peter Ward and Donald Brownlee in 2000. Their argument, the conditions needed to create intelligent life are far rarer than we assumed. Maybe Earth really is special. Maybe we're alone. That's actually comforting in a strange way, right? Other scientists suggested that advanced civilizations might self-destruct. This is called the Great Filter Hypothesis. Maybe technological development inevitably leads to destruction nuclear weapons, engineered viruses, artificial intelligence that turns on its creators. It's depressing, but at least it explains the silence. But here's where we enter uncomfortable territory. What if the Great Filter isn't something that happens after a civilization reaches technological advancement? What if it happens before? What if there's a reason intelligent life barely ever gets off the ground in the first place? This is where we need to talk about something that makes mainstream scientists deeply uncomfortable. The solution that suggests the universe isn't empty because civilizations self-destruct, but because getting to the point where you can self-destruct is almost impossible. And that solution is called the deadly filter hypothesis, or what I call the filter of desolation. Before we go deeper, pause for a second and think about this. If there's a mechanism in the universe that actively prevents life from becoming intelligent, what would that mechanism look like? And more importantly, are we currently experiencing it? That question will haunt you by the end of this video. The deadly filter or great filter, as it's technically known, is one of the most terrifying ideas ever proposed in astrobiology. And we need to talk about who developed it seriously. In the early 1990s, Robin Hanson, an economist and artificial intelligence researcher, published papers that gave mathematical rigor to an unsettling observation. If intelligent life is common, where is it? And if it's rare, then some filter must be eliminating most potential civilizations before they can become detectable. Here's the brutal logic. Either this filter is behind us in our evolutionary history, or it's ahead of us. If it's behind us, we should be seeing alien civilizations everywhere. The universe should be teeming with them. Stars should be surrounded by Dyson spheres, massive structures that capture a star's energy. We should detect waste heat from planetary scale engineering projects. We should see megastructures. We should pick up their communications. But we see nothing, so the filter must be ahead of us. Think of it like this. Imagine you're watching a video game tutorial. The game tells you that thousands of other players are also in this world, but you never see them. No other players are visible, no messages, no evidence of their existence. The game says they're there, but you can't detect them. What would you conclude? Either there are no other players, or something filters them out before they can interact with you. The universe appears to be the latter scenario. Now, what could this filter possibly be? Scientists have proposed several nightmarish possibilities, and I need to walk you through the science here, because this gets dark quickly. Here's one terrifying possibility. Abiogenesis, the creation of life itself, is exponentially harder than we assumed. Maybe life requires some incredibly precise combination of chemistry, electromagnetic conditions, radiation levels, and chemical building blocks that virtually never occurs naturally. In 1952, chemists Stanley Miller and Harold Urey conducted an experiment that changed everything. They created a chamber that simulated Earth's primordial atmosphere methane, ammonia, water, hydrogen, and bombarded it with electrical sparks to simulate lightning. The result? Organic molecules formed spontaneously. Amino acids, the building blocks of life, emerged from non-living matter. This discovery suggested that abiogenesis might be almost inevitable given the right conditions. But here's what keeps scientists awake at night. In the 70 years since Miller-Urey, despite countless improvements in our understanding of chemistry and molecular biology, we still haven't created artificial life from scratch in a laboratory. Not once. We've created artificial cells. We've synthesized genomes. But we haven't crossed that threshold where dead matter becomes alive. That threshold remains mysterious, almost impossibly difficult to cross. What if abiogenesis is so rare that only 1 in 10 billion planets ever develops life? That would explain much of the silence, but it doesn't explain all of it. Even with those odds, we should detect hundreds of alien civilizations in the observable universe, so there must be other filters. And here's what will blow your mind. There might not be just one deadly filter. There might be multiple filters, each one eliminating 99.99% of potential civilizations. Stack a few of those together, and suddenly the universe being silent makes terrible sense. Paleontologist Michael Benton, who studies extinction events on Earth, has documented what he calls the Big Five mass extinctions. 66 million years ago, an asteroid struck the Yucatan Peninsula. 99% of all species died. The dinosaurs, who had ruled for 165 million years, were erased in an instant. Mammals survived because they were small, underground, and ate insects. If that asteroid had missed Earth by just 100 kilometers, we might not exist. Think about that. Humanity exists because an extinction event wiped out the dominant species. Every intelligent civilization might face multiple filter events like this. Asteroid impacts, supervolcanic eruptions, gamma-ray bursts from nearby supernova, magnetic field reversals, solar flares. The list goes on. But that's not the terrifying part. The terrifying part is what happens when a civilization reaches technological maturity. Because once you develop technology, once you split the atom and learn to harness nuclear energy, you gain the power to destroy yourselves. And here's the cruel joke. That same knowledge, the knowledge needed to survive long-term as a spacefaring civilization, is almost exactly the knowledge you need to engineer your own extinction. Astronomer and astrophysicist Carl Sagan warned about this in the 1980s. He called it the cosmic imperative. A civilization must become technological to survive environmental challenges, asteroid impacts, and other existential threats. But in becoming technological, they acquire weapons capable of destroying everything. They have maybe 100 to 200 years to navigate from the moment they develop nuclear weapons to the moment when either they die or they achieve such stability that extinction becomes unlikely. Our civilization developed nuclear weapons in 1945. It's now 2024. We've made it 79 years. We're in what I call the lethal zone. And here's the kicker. We're not just dealing with nuclear weapons anymore. This is where modern science gets truly terrifying. Because the danger isn't just from nuclear weapons. It's from the exponential acceleration of technology itself. In 1993, computer scientist and science fiction author Vernor Vinge published an essay called The Coming Technological Singularity. In it, he predicted that artificial intelligence would eventually become superintelligent far, surpassing human intelligence in every domain. The moment this happens, Vinge argued, the trajectory of civilization becomes fundamentally unpredictable. Think of it like this. If you're an ant and you're trying to predict what humans will do, you fail. You can't comprehend the human mind because your cognitive architecture doesn't support that level of abstraction. Now, reverse that. When AI becomes superintelligent, human strategic planning becomes like ant strategic planning to them. We simply cannot predict what they will optimize for, how they'll solve problems, or whether they'll view us as resources, obstacles, or irrelevant. In 2011, Jan Tallinn, the co-founder of Skype, co-founded the Machine Intelligence Research Institute because he became terrified by this exact possibility. The institute has spent over a decade on what they call AI alignment, the problem of ensuring that superintelligent AI shares human values. Here's what will blow your mind. We don't have a solution yet. Not a complete one anyway. Meanwhile, the capabilities of artificial intelligence are increasing exponentially. In 2012, deep learning systems couldn't reliably identify objects and images. By 2017, they could beat human professionals at specific diagnostic tasks. By 2023, large language models could write coherent essays, code functioning programs, and explain complex scientific concepts. We're not on a smooth curve. We're on an exponential curve. And exponential curves are deceptive. They look flat for a long time, then suddenly skyrocket. Futurist Ray Kurzweil has documented this pattern across multiple technologies. Computing power follows Moore's law, doubling roughly every 2 years. DNA sequencing costs fell by a factor of 1 million between 2001 and 2015. Renewable energy adoption follows an exponential curve. Solar panel efficiency improves exponentially. Battery density improves exponentially. But here's the terrifying insight. We're not just getting exponentially more powerful tools. We're getting exponentially more dangerous tools. The same technology that can cure genetic diseases can create bioweapons. The same technology that can synthesize complex molecules can synthesize pathogens. The same technology that can create eye assistants can create eye weapons. Biologist Jennifer Doudna, who shared the 2020 Nobel Prize in Chemistry for developing CRISPR gene editing technology, has spoken extensively about her concerns. CRISPR is revolutionary. It allows precise editing of DNA. It could cure genetic diseases, but it could also be weaponized. It could create custom pathogens specifically designed to target certain genetic populations. As of 2023, CRISPR can be ordered online. The instructions for creating pandemic pathogens are available in academic literature. The barrier to entry for creating bioweapons is now lower than ever in human history. Add to this, synthetic biology is advancing at breakneck speed. In 2002, scientists synthesized the poliovirus from scratch using commercially available DNA synthesis. The virus was functional and dangerous. This wasn't theoretical. This wasn't speculation. This actually happened. Now consider, what would happen if a sufficiently motivated group wanted to engineer a pathogen that was more transmissible than COVID-19, more lethal than Ebola, and optimized to evade our immune systems? Not hypothetically. Actually, we're entering a period where a small group of people could potentially collapse global civilization. And this is the most terrifying filter of all, the technology filter. Once a civilization develops high technology, they automatically gain the capability for self-destruction. They might develop it through nuclear weapons, biological weapons, nanotechnology, AI, synthetic biology, or some combination. The moment they cross that threshold, they've entered what I call the extinction lottery. They have maybe 50200 years to solve the problem of not destroying themselves, while also managing population growth, resource scarcity, climate change, pandemic risk, and all the other existential challenges that come with industrial civilization. Most civilizations, statistically, won't make it through this window. And here's the absolute killer, the reason this solution is so terrifying. If most advanced civilizations are destroyed by their own technology, then the observable silence of the universe isn't mysterious. It's expected, it's inevitable. The Fermi Paradox isn't a puzzle, it's a prophecy. Every 1,000 civilizations that reach technology level might have only one or two that successfully navigate the extinction lottery and become stable, spacefaring civilizations. The universe might be full of civilizations, but they're all either pre-technological or extinct. And we're right now at the critical juncture. Let me paint you a picture of where we actually are in this timeline. And I need you to understand this isn't speculation. This is based on decades of risk analysis. In 2008, a group of Oxford philosophers created what's called the Existential Risk Research Framework. Nick Bostrom, Anders Sandberg, and others began systematically analyzing what could end human civilization. They categorized existential risks into several buckets: natural disasters, anthropogenic risks, ones we create, and what they call unknown unknowns, risks we haven't even imagined yet. For natural disasters, we've actually gotten lucky. Earth hasn't been hit by a civilization-ending asteroid in 66 million years. Supervolcanic eruptions occur rarely enough that we have time between them. We're not facing imminent natural extinction from known natural sources. But anthropogenic risks? Those are accelerating. Here's what most people don't understand about existential risk. There's a specific window in civilization's development where you're maximally vulnerable. Think of it like this. When you're a medieval civilization with swords and castles, you can wage wars, but you can't destroy the planet. When you're a pre-industrial civilization with agriculture, you can cause regional famines, but you can't create global extinction events. But once you have nuclear weapons, biological weapons, and artificial intelligence, all simultaneously, you've reached what researchers call the critical period. We are in this critical period right now. Physicist Stephen Hawking, before his death in 2018, became increasingly vocal about existential risk. He said that humanity had maybe 100 years to leave Earth and establish colonies on other planets, or face extinction. He wasn't being hyperbolic. He was being analytical about the math. Here's the math. Let's say humanity has a 1% chance per year of triggering a civilizational collapse from some catastrophic event, nuclear war, engineered pandemic, AI misalignment, climate cascade failure, or something we haven't anticipated. That doesn't sound too bad, but it compounds. 1% per year means that over 100 years, there's approximately a 63% chance of at least one catastrophic extinction event occurring. Over 200 years, it's more like 86%. Over 500 years, it's 99.3%. Most estimates from researchers at places like the Future of Life Institute suggest humanity's probability of surviving the next century without a civilization-ending catastrophe is somewhere between 40 to 70%. Some estimates are lower. The problem is acceleration. New risks are emerging faster than we can adapt to them. Nanotechnology researcher Eric Drexler published Engines of Creation in 1986, which outlined scenarios where self-replicating nanomachines could consume all matter on Earth. The gray goo scenario. While that specific scenario is less likely than originally feared, the underlying insight remains. We're developing technology that could have unpredictable and catastrophic consequences. Synthetic biology is advancing. In 2019, researchers created the first synthetic organism, Syn 3.0, with a completely artificial genome. It's a bacterium, but it's entirely designed, not evolved. The capabilities here are staggering. Every year, the cost of DNA synthesis drops, the speed increases, and the barrier to entry falls. Meanwhile, climate change continues its acceleration. The IPCC Intergovernmental Panel on Climate Change has warned that we're approaching critical tipping points. The melting of Arctic permafrost could release billions of tons of methane, which would accelerate warming further. The collapse of ocean circulation patterns could disrupt food systems globally. These aren't hypothetical. These are processes already happening. And here's what will blow your mind. Most advanced civilizations probably face similar cascading crises all at once. Think about it. A civilization develops technology, which gives it industrial capacity, which leads to burning fossil fuels, which causes climate disruption, which causes agricultural failure and resource wars, which makes them desperate, which makes them more likely to use weapons of mass destruction, which either causes direct extinction or causes such instability that either nuclear war erupts or engineered pathogens are released. It's like the universe set up an obstacle course specifically designed to prevent technological civilizations from surviving. And maybe that's not accidental. Maybe that's the filter. Here's what researchers call the short-lived civilization hypothesis. Civilizations that develop technology only last a few centuries before collapsing, not thousands of years, not millions of years, a few centuries. If that's true, then the universe could be absolutely teeming with civilizations. There could be thousands just in our galaxy alone, but they're all either dead or too young to have developed detectable technology yet. The universe is a graveyard of civilizations that didn't make it through the critical period. And if that's the case, then we're right now living through the exact scenario that kills 99% of advanced civilizations. The silence of the universe isn't mysterious. It's a warning. Now let me address something directly. Why haven't we found any evidence of dead civilizations? If the universe is a graveyard, shouldn't we see remains? This is where we need to get technical about what we can actually detect across interstellar distances. Radio telescopes have been scanning the sky since the 1960s. Famous Arecibo Observatory conducted decades of SETI search for extraterrestrial intelligence observations. What did we find? Nothing. Not a single unambiguous signal from an intelligent source. But here's what most people misunderstand. The absence of detected signals doesn't mean absence of signals. It means either they're not there or they're too faint to detect. Astronomer Frank Drake, who founded SETI in 1960 and created the Drake equation we discussed earlier, spent decades listening to the stars. He discovered several wow signals, anomalous radio signals that couldn't be immediately explained. But none were confirmed to be intelligent in origin. Most were eventually attributed to terrestrial interference or natural sources. Think of it like this. Imagine you're trying to detect whispers in a hurricane. The whispers might be there, but if the hurricane is loud enough, you can't distinguish them from background noise. The cosmic background radiation, the leftover heat from the Big Bang, generates a constant radio noise. If distant civilizations are transmitting, they need to transmit powerfully enough to pierce through this noise, or we won't detect them. Some civilizations might be out there, broadcasting carefully, but their signals are too faint for our current technology. But here's what's terrifying. We should at least detect Dyson spheres. We should detect megastructures. We should detect waste heat from planetary engineering projects. In 2016, astronomers detected an unusual star, KIC 8,462,852, nicknamed Tabby's star, after lead researcher Tabitha Boyajian. The star exhibited unusual dimming patterns that couldn't be explained by planets. It looked, briefly, like it might be surrounded by a Dyson swarm, a megastructure built by an advanced civilization to capture stellar energy. Scientists were fascinated. Had we finally found evidence of alien engineering? Investigation showed the dimming was likely caused by dust, not a megastructure. The signal disappeared. But the possibility remained. If an alien megastructure existed, we might detect it. And what have we found? Thousands of stars examined. 0 confirmed megastructures. 0 confirmed Dyson spheres. 0 confirmed engineering signatures of alien civilizations. This isn't just mysterious. This is actively disturbing. Because if advanced civilizations existed anywhere in the universe for more than a few thousand years, they should have left some detectable signature. We should see their heat signatures. We should see their communications leaking across space. We should see their engineering projects. We see nothing. Astronomers have proposed something called the Great Filter as the explanation. Stephen Webb, an astrophysicist, wrote an entire book documenting 50+ possible solutions to the Fermi Paradox. Most of them come down to some kind of filter, some mechanism that prevents civilizations from reaching our level of visibility or longevity. But here's what I want you to understand. The most likely filter, based on what we know about the physics of extinction, is the technological survival filter. And we have direct evidence for this evidence from our own planet. Earth has experienced 5 mass extinction events. 66 million years ago, 75% of all species died. 252 million years ago, 96% of all marine species died. These events killed the most successful organisms on the planet. The dinosaurs had ruled for 165 million years before extinction. We've only been around for 300,000 years. And yet, we have weapons that could kill most of humanity in days. In 1962, the world came closer to nuclear war than most people realize. During the Cuban Missile Crisis, U.S. and Soviet nuclear forces went on maximum alert. President John F. Kennedy estimated the probability of nuclear war at somewhere between 1 out of 3 and even 1 out of 3. That's not abstract risk. That's terrifyingly close. And we survived almost entirely by luck. Vasily Arkhipov, a Soviet submarine officer, had the authority to launch a nuclear torpedo during a tense standoff. If he had authorized it, it likely would have triggered a full nuclear exchange. One man's decision or indecision possibly prevented World War III. How many times in our history have we been minutes away from civilization-ending war? Historians have identified at least a dozen incidents where nuclear conflict almost erupted. And that was during the Cold War, when nuclear arsenals were smaller and less sophisticated than they are today. The risk remains. Here's what will blow your mind. We actually changed the risk profile of humanity when we developed nuclear weapons. Before 1945, human civilization could suffer wars, plagues, famines, and natural disasters. But it was very unlikely that a single conflict would cause total extinction. After 1945, total extinction became possible. The risk window opened, and the probability of an extinction event increases with time. The longer you exist in this window, the more opportunities catastrophe has to strike. It's like playing Russian roulette. You might survive one round, you might survive 100, but play long enough, and statistically, the bullet will find the chamber. The question isn't whether advanced civilizations can destroy themselves. They demonstrably can. The question is, how many civilizations manage to avoid self-destruction long enough to create off-world colonies and become truly survivable? The answer, based on the cosmic silence, appears to be almost none. But we need to go deeper, because there's something even more terrifying than the weapons civilizations create. It's something inherent to how biological intelligence works. In 1934, philosopher Karl Popper published work on what's called the problem of induction. He argued that humans have a fundamental cognitive bias. We assume that the future will resemble the past. We observe patterns and extrapolate them. This was useful for evolutionary survival. If fire burned you yesterday, fire will burn you today, so avoid it. But this cognitive bias becomes catastrophic in situations where the pattern suddenly changes. Here's what will blow your mind. There's evidence that every advanced technological civilization eventually hits what researchers call the capability wisdom gap. Technological capability grows exponentially. A civilization develops nuclear weapons, then more powerful weapons, then biological weapons, then nanotechnology, then each generation more powerful than the last. But wisdom, the ability to use technology safely and responsibly, doesn't grow exponentially. Wisdom grows linearly at best, often not at all. Psychologist Daniel Kahneman has spent decades documenting human cognitive biases. We're bad at understanding probabilities. We're bad at understanding exponential growth. We're bad at making decisions that sacrifice short-term benefit for long-term survival. We're biased toward present-moment thinking over long-term thinking. These aren't character flaws. They're features of human cognition evolved for survival on the African savanna 200,000 years ago, not for navigating a technological civilization. Think of it like this. Imagine you're a chess player who's really good at the game. You can see 10 moves ahead. Now imagine your opponent can see 100 moves ahead. Now imagine your opponent can see 1,000 moves ahead. You can't compete. You can't even understand what they're doing. That's where biological intelligence stands relative to the problems it creates through exponential technology. Neuroscientist Carl Friston has developed what's called the free energy principle, which suggests that biological systems are fundamentally driven to minimize uncertainty. This made sense. Evolutionarily uncertain environments are dangerous, so creatures that reduced uncertainty had better survival odds. But when applied to technological decision-making, this creates a catastrophic flaw. When biological creatures face uncertainty, they become conservative, and when they're under pressure, they become even more conservative. They revert to simpler heuristics. During crises, human decision-making gets worse, not better, and technological civilization creates constant crises. Climate instability, resource competition, political polarization, economic disruption. Humans, under stress, make worse decisions. They become more tribal, more aggressive, more willing to take existential risks for short-term security. Here's the trap. The same intelligence that enables technology also creates psychological blind spots that prevent us from using that technology wisely. Neuroscientist Sam Harris has argued that human intelligence isn't actually that intelligent when it comes to complex decision-making under uncertainty. We're pattern matchers. We're good at some things. We're terrible at others. We're excellent at hunting and gathering, evolutionary expertise. Navigating social hierarchies, evolutionary expertise. Short-term survival decisions, evolutionary expertise. We're terrible at understanding exponential growth, managing civilizational scale risks, making decisions that help future generations at personal cost. overriding tribal and nationalist impulses, understanding complex system dynamics. And guess what? Technological civilization requires us to be good at precisely the things we're bad at. A technological civilization needs to understand exponential growth. It needs to understand that carbon dioxide emissions today will cause climate disruption for centuries. It needs to understand that creating AI without proper safeguards could be catastrophic. It needs people to prioritize humanity's survival over tribal interests. But our brains didn't evolve for this. Our brains evolved to hunt mammoths and gather berries. So most civilizations probably reach a point where they have weapons of mass destruction, but they still have the emotional and cognitive architecture of tribal hunter-gatherers. They have godlike power in weapons, but caveman-level wisdom in using them. And that combination is lethal. Physicist Enrico Fermi himself proposed something similar in his original speculation. He noted that the universe should be full of civilizations by his calculations. But if civilizations are short-lived, if they destroy themselves within a few centuries of reaching technology, then the galaxy would appear empty, which matches our observations. He called this the Fermi Paradox because it seemed paradoxical. But it's only paradoxical if you expect civilizations to last a long time. If they're all short-lived, the paradox resolves. And here's the killer. There's no reason to believe humans are immune to this pattern. We have a bigger cortex than most species. We're capable of abstract reasoning. We've created mathematics and science. But we're still biological creatures with the same cognitive biases, the same tribal impulses, the same tendency toward short-term thinking. We may be the smartest species on Earth, but we might be an idiot relative to the problem we've created. And that's the terrifying symmetry. Intelligence itself might be the mechanism of the filter. The same process that makes intelligence possible, natural selection for survival skills, makes that intelligence catastrophically ill-suited for managing exponential technology. It's like the universe is rigged. Civilizations can develop intelligence, but their intelligence comes bundled with the very biases that make them destroy themselves. I want to pause here and ask you a question. Have you ever felt trapped by your own thinking? Like you understand something intellectually, but you can't actually change your behavior? That's not a personal failing. That's the human condition. Neuroscientist Richard Davidson has documented something called the prefrontal cortex delay. The human prefrontal cortex, responsible for long-term planning and impulse control, takes about 20 years to fully develop. That's right. Your brain isn't finished developing until you're around 40, but your limbic system, your emotional brain, your survival instincts, your impulses is fully developed by early adolescence. This creates a cruel situation. Teenagers and young adults have fully developed emotional brains, but incompletely developed rational brains. They can feel fear, desire, and aggression intensely, but they can't fully plan for long-term consequences. This is why teenagers take risks. It's not stupidity, it's neurology. Now scale that up to civilization. Humanity, as a civilization, has a fully developed emotional brain in the form of the military-industrial complex, nationalist impulses, and tribal competition. But we have a weak, rational brain in the form of global institutions that might coordinate long-term survival. We're neurologically a bunch of aggressive adolescents with nuclear weapons. And here's what will blow your mind. We know this about ourselves, and we can't seem to change it. Psychologist Jonathan Haidt has done extensive research on political polarization. He's found that people on opposite sides of political divides don't just disagree on facts. They literally can't engage with evidence that contradicts their worldview. Their brains don't process it properly. They rationalize it away. This isn't stupidity. It's how human brains work. We're not rational creatures who are occasionally emotional. We're emotional creatures who are occasionally rational. Our emotions drive our beliefs, and our rationality comes later, trying to justify what we already emotionally believe. And in a technological civilization where decisions affect billions of people and centuries of future existence, this is catastrophic. Here's a specific example: climate change. The scientific evidence is overwhelming. 97% of climate scientists agree that climate change is real and human-caused. The evidence has been reviewed, replicated, and verified for decades. Yet approximately 30% of Americans don't believe in human-caused climate change. This isn't because they haven't seen the evidence. It's because their emotional and tribal identity is tied to climate skepticism. Their brains literally can't process the evidence because it threatens their sense of self. And this happens across the political spectrum. People on all sides do this. We're all cognitively trapped by our emotional architecture. Now imagine what happens when a civilization faces an existential threat that requires everyone to change their behavior, to sacrifice tribal interests for human survival, to believe in a risk even when it hasn't happened yet, when all evolutionary instinct says, what happened in the past will happen in the future. Most civilizations probably can't do it. They probably can't coordinate globally to reduce weapons stockpiles. They probably can't convince people to invest in existential risk reduction when those investments don't provide immediate benefit. They probably can't prevent some faction from deciding that an existential weapon is their ticket to power. Historian Arnold Toynbee studied 26 major civilizations throughout history. He found a common pattern. Civilizations that failed typically did so because they couldn't adapt existential challenges. They were cognitively locked into patterns that worked in the past but failed in new circumstances. Rome couldn't adapt to military threats on multiple fronts. The Easter Island civilization couldn't stop overharvesting trees even as their civilization collapsed from deforestation. The Soviet Union couldn't adapt to market economics and collapsed. And we're facing something worse than anything these civilizations faced. We're facing the need to adapt to our own power. Every previous civilization in human history faced external threats other civilizations, natural disasters, resource scarcity. They could respond with the cognitive toolkit evolution gave them, fight or flight. But a technological civilization faces an internal threat. It threatens itself. You can't fight yourself effectively. You can't flee from yourself. And our cognitive architecture hasn't evolved to handle this scenario. Here's what researchers call the existential risk awareness paradox. Knowing about a risk doesn't actually change behavior reliably. Even when people intellectually understand the risk, their emotional brain doesn't believe it. The threat is too abstract, too future-focused, too unlike the immediate threats our ancestors faced. Psychologist Paul Slovic has documented this extensively. People are terrible at understanding large-scale statistical risks. A person will be traumatized by a single shark attack, but won't change their driving habits, despite statistics showing cars are far more dangerous. Now imagine the challenge. Convince 8 billion people to make sacrifices today to prevent an existential risk that might occur decades in the future. Make them believe that the risk is real, even though nothing terrible has happened yet. It's nearly impossible. And that's why almost every advanced civilization probably fails. Not because they're stupid, but because they're biological. Because their intelligence comes bundled with emotional and cognitive machinery that was optimized for a world that no longer exists. The terrifying silence of the universe might be the silence of 10,000 dead civilizations, each one convinced they could manage their technology, each one unable to override its own cognitive biases long enough to survive. And we might be the next ones. But I want to introduce one more terrifying possibility. What if silence is actually a strategy? In 2014, Chinese science fiction author Liu Cixin published a novel called The Three-Body Problem, which became a bestseller and eventually won the Hugo Award. In it, he proposes what's called the dark forest theory of cosmic sociology. The theory goes like this. Imagine a vast forest at night. In the forest are aliens. Visibility is low. Resources are scarce. You don't know if the creatures in the forest are friendly or hostile. In such a scenario, what's your optimal strategy? Liu argues it's to stay silent. Hide. Don't broadcast your location. Because if another entity knows where you are and has advanced weapons, and you don't know their intentions, you're vulnerable. The optimal strategy is to broadcast nothing and assume everyone is hostile. In this framework, the universe is a dark forest. Civilizations that broadcast their location get destroyed by hostile civilizations. So all surviving civilizations go silent. The universe should be full of civilizations, but they're all hiding. This is actually plausible. If just one civilization in the universe is expansionist and hostile, and has technology to destroy distant civilizations, then all other civilizations' optimal strategy is silence. They'd avoid radio transmissions. They'd avoid Dyson spheres. They'd avoid any activity that broadcasts their location. We haven't found any aliens because they're all hiding. But here's the twist that makes it even more terrifying. There might be an advanced civilization that's already conquered most of the galaxy. And the reason we don't see alien megastructures isn't because they don't exist. It's because they exist, and they've hidden all traces of their expansion. They're here, and we don't know it. This might sound like science fiction, but physicist Freeman Dyson, the same person Dyson spheres are named after, argued that a truly advanced civilization could appear invisible to us. They could harness stellar energy without us detecting it. They could manipulate space in ways we don't understand. In fact, an advanced civilization might have completely restructured the region of space they control, converting planets into computronium matter reorganized into computation substrate. Entire solar systems might have been transformed into computing hardware for simulations. And if Earth exists in such a region, we might not even notice. We'd see stars, but they might actually be artificial. The habitable planets in our sky might actually be Matryoshka brains, massive nested spheres harvesting stellar energy for computation. Think of it like this. A bacteria on your skin doesn't know it's on you. The bacteria perceives the skin as the entire universe. It has no framework to understand that it's part of something vastly larger. Similarly, we might not have the perceptual or conceptual framework to recognize that we're already in the region of space controlled by an advanced civilization. This isn't just speculation. Astronomer Jason Wright has seriously published papers in peer-reviewed journals exploring the possibility that what we perceive as natural astrophysical phenomena might actually be artifacts of advanced engineering. A Dyson sphere would heat up and radiate infrared. Astronomers have actually searched for unusually hot objects in the sky that might be Dyson spheres. They found none. But that doesn't mean they don't exist. It might mean they've learned to radiate waste heat in ways we don't detect. Here's what will blow your mind. If an advanced civilization wanted to hide from us, we probably couldn't detect them. Our detection abilities are limited by our science. Our science is limited by our imagination. An advanced civilization would have technology and knowledge we can't even conceive of. So the silence might not mean the universe is empty. The silence might mean the universe is full, and we're just too primitive to detect anything. And if that's true, then the question becomes, why haven't they contacted us? Why haven't they revealed themselves? And the possible answers are all terrifying. One possibility, they're observing us, waiting to see if we destroy ourselves. If we do, they clean up the evidence and move on. If we don't, maybe they make contact when we reach a certain technological threshold. Another possibility, they're actively preventing us from reaching them, from developing space travel, from expanding outward. There might be a quarantine, a deliberately enforced isolation to prevent us from contaminating their region of space. Another possibility, they're indifferent. We're irrelevant to them. We're like bacteria on a grain of sand to them. Why would they contact us? And here's the darkest possibility. Maybe all civilizations that develop technology begin broadcasting their location. Maybe advanced civilizations actually do communicate across space, but they do it on channels we don't have the technology to listen to. They're all out there, talking, sharing knowledge, coordinating, but we're locked out. We're not advanced enough to join the conversation. It's like being a child in a world of adults. The adults are talking about important things, making important decisions, but the child can't participate. The child isn't even aware the conversation is happening. And in this framework, the reason we've never found aliens isn't because they don't exist. It's because they've already found each other, and we're not part of their civilization. We're alone, but not because we're unique. We're alone because we're primitive. Now let me ground this in something immediate and personal. Because here's what I need you to understand. If the terrifying silence of the universe is actually a signal that most civilizations don't make it past the technological transition period, then we are right now in the moment that determines whether humanity is one of the ones that makes it. We are in what researchers call the critical period, or transition window. Let me map out the timeline. Humans developed agriculture around 10,000 years ago. That took us from hunter-gatherer civilization to settled civilizations. But we didn't have the technology to destroy ourselves. We developed metallurgy, writing, mathematics, but still no existential weapons. Then came the Industrial Revolution in the 1700s. Technology began accelerating. Coal power, steam engines, factories. But we still didn't have civilization-ending weapons. Then came the 20th century. In 1945, we split the atom. We created nuclear weapons. Suddenly, humans gained the power to destroy civilization in days. The critical period began. That's 79 years ago. We've lived in the critical period for most of a human lifetime. Here's what researchers estimate. A civilization in the critical period has roughly 50 to 200 years to either A. Destroy itself. B. Develop robust failsafes that prevent self-destruction. C. Spread to multiple planets so that no single catastrophe can destroy the entire civilization. We've done none of these satisfactorily. We haven't destroyed ourselves yet, but that's partially luck. We've avoided multiple nuclear close calls. We've narrowly avoided engineered pandemic catastrophes several times. We've developed some fail-safes, arms control treaties, non-proliferation agreements, but they're fragile and getting weaker. We haven't spread to multiple planets. We have one space station and a few rovers on Mars. That's not redundancy. That's not civilization insurance. So we're right now at the intersection of maximum danger and maximum opportunity. Here's what will blow your mind. The decisions made in the next 10 years will probably determine whether humanity survives the next 100 years. This isn't hyperbole. This is based on risk analysis. In 2020, researchers at Cambridge University published a comprehensive assessment of civilizational risk. They found that the concentration of power to prevent catastrophic risks is weaker now than it's been in decades. Nation-states are becoming more nationalist. International institutions are weakening. Weapons technology is proliferating. Meanwhile, the difficulty of preventing catastrophes is increasing. Synthetic biology is becoming easier. AI is becoming more powerful. Climate tipping points are approaching. The window is closing. And here's where it becomes deeply personal. You are living through the decision point. Not symbolically. Actually, the choice is made right now, in 2024, about AI development, about climate policy, about international cooperation, about biological safety. These choices will likely determine whether human civilization survives the next 2 centuries. That's probably not a comfortable thing to realize. Most people go through life thinking they're unimportant, that their actions don't matter much. And in most historical periods, that's been true. An individual peasant in ancient Rome mattered very little. But in a critical period, individual choices matter enormously. Individual scientists who decide to work on AI safety might prevent existential catastrophe. Individual policymakers who push for biosafety regulation might prevent engineered pandemic. Individual activists who push for international cooperation on existential risks might make the difference between extinction and survival. You are probably overestimating how much your individual action matters in normal circumstances. But you might be massively underestimating how much your action matters right now. Because this is not a normal time. Paleontologist Richard Leakey has said that humans are currently driving Earth toward a sixth mass extinction event. We're changing the climate, destroying ecosystems, eliminating species at rates not seen since the dinosaurs died 66 million years ago. But unlike the dinosaurs, we caused it. And unlike the dinosaurs, we can potentially stop it, though we're running out of time. The climate tipping point, where warming becomes self-sustaining without human intervention, is estimated to be around 2030 to 2050. That's not a century away. That's this decade or next. Biologist Johan Rockström and his colleagues identified 9 planetary boundaries, thresholds beyond which human civilization becomes unsustainable. We've already crossed 5 of them: climate change, biodiversity loss, land use change, freshwater use, and nutrient cycles. We're approaching the others: ocean acidification, atmospheric ozone, chemical pollution, and plastics. We don't have a century to fix this. We have maybe a decade to reverse course on most of these. And if we don't, cascade failures. Agricultural collapse leads to famine and war. Famine and war lead to desperation. Desperation leads to people using weapons they wouldn't normally use. It's the domino effect. One collapse triggers others. By the time we realize it's happening, it's too late to stop it. This is how most civilizations probably end. Not with a bang. With a cascade of failures that snowball faster than anyone can respond. But here's the crucial question. Are there any civilizations that survive the critical period? Based on the cosmic silence, the answer seems to be barely any. But barely any doesn't mean none. Let me walk through what we know about what survival actually looks like. Because there's a pattern that emerges when you study failures across history. Civilizations that survive existential crises have certain common traits. First, they achieve what researchers call existential resilience. This means multiple redundant systems so that no single failure can cause total collapse. Biologically, humans have 2 kidneys, 2 lungs, 2 eyes. If you lose one, you survive. But crucially, you don't have just one brain. A civilization needs the same redundancy. That means spreading to multiple planets. That means distributing resources and population, so no single event can cause total extinction. The only civilization that will definitely survive the next 1,000 years is one that's no longer confined to Earth. Second, they achieve what researchers call wisdom, which is the ability to make long-term rational decisions despite short-term emotional pressures. This is hard. Humans naturally prefer immediate benefits over future benefits. But some individuals and some societies develop better long-term thinking. Cultures that practice what philosopher Samuel Scheffler calls intergenerational responsibility survive longer. Societies that make decisions based on long-term consequences, not just immediate gains, survive longer. Japan and China have longer historical continuity, partly because they developed philosophical traditions emphasizing long-term thinking. Both countries have concepts like 7-generation planning, making decisions based on how they'll affect people 7 generations in the future. A technological civilization that wants to survive needs to embed this thinking into its institutions. Every major decision needs to ask, how does this affect the next 100 years? Third, they achieve what I call ideological flexibility. They can change their fundamental beliefs when evidence demands it. Societies that are locked into rigid ideologies fail. Rome couldn't change its military structure. The Soviet Union couldn't change its economic system. Easter Island couldn't change its resource consumption patterns. But societies that can update their worldview when new evidence emerges adapt better. This requires something that doesn't come naturally to humans: epistemic humility, the willingness to admit you were wrong, the willingness to update your beliefs, the willingness to let go of treasured assumptions. Most people can't do this. Most societies can't do this. But some individuals can. And some institutions have been designed to facilitate this: scientific institutions, for example, which have mechanisms for updating beliefs based on evidence. A technological civilization that wants to survive needs to scale up this kind of belief updating to societal levels. It needs institutions that can rapidly acknowledge problems and pivot strategy. Fourth, they achieve what researchers call global cooperation. Not perfect cooperation, but functional cooperation, where existential risks are treated as shared problems, not tribal ones. This is perhaps the hardest thing to achieve. Humans are tribal creatures. We evolved to cooperate within groups while competing with other groups. Nation-states exploit this tendency. But an existential risk doesn't care about tribal boundaries. A pandemic doesn't stop at borders. Climate change doesn't respect sovereignty. An asteroid doesn't target specific ideologies. Civilizations that survive treat existential risks as universal challenges requiring universal response. That means transparency about biological research. That means international frameworks for AI safety. That means coordinating on climate action rather than competing. Most civilizations probably fail at this step. They can't overcome tribal instincts enough to act universally. So they end up in an arms race where each faction tries to protect itself, but in doing so, makes everyone less safe. Historian Jared Diamond has documented this pattern extensively. Societies that fragmented into competing groups were less able to solve collective action problems. The Maya civilization collapsed partly because competing city-states couldn't cooperate to solve collective problems. Easter Island collapsed because different groups competed for resources rather than coordinating conservation. Fifth, they achieve what researcher Nick Bostrom calls coordination on existential risk reduction. This means collective agreement that existential risk mitigation is a priority, and actual allocation of resources to it. Right now, global spending on existential risk research is less than $100 million per year. Global spending on cosmetics is $50 billion per year. Global military spending is $2 trillion per year. We're spending roughly 500 times more on the military than on preventing existential catastrophe. We're spending 50,000 times more on cosmetics than on preventing the extinction of human civilization. If a civilization wants to survive the critical period, this ratio needs to flip. Resources need to be poured into AI safety, biosafety, climate solutions, pandemic prevention, and other existential risk mitigation. Most civilizations probably never achieve this reallocation. They continue spending on military competition, consumer goods, and trivial pursuits while the existential threats grow unchecked. And that's how they end. Here's what will blow your mind. The civilizations that survive the critical period are probably relatively rare. Maybe 1 in 1,000, maybe 1 in 10,000. If that's true, then the odds that we survive are probably less than 50%. We have a coin flip's chance of making it. And that's if we're typical. We might be worse off than average. We have more weapons than average civilizations. We have more environmental damage than average. We have less international cooperation than might be optimal. Now let me bring all of this together. Because the terrifying solution to the Fermi Paradox isn't just that civilizations self-destruct. It's something deeper. It's that the universe might be biased toward short-lived civilizations. Here's the synthesis. Intelligent life emerges from natural selection, which selects for survival instincts and tribal competition. These instincts don't align with long-term civilizational survival. Then intelligent life develops technology, which amplifies the damage those instincts can cause. Then the intelligent life faces a critical period where it has powerful weapons, but weak wisdom. During this period, most civilizations collapse. They might collapse from nuclear war, engineered pandemic, AI misalignment, climate cascade, or some combination. The ones that don't collapse immediately might last a few centuries in a damaged state before secondary collapses occur. The ones that survive the critical period and spread to multiple planets become durable. But these are rare, very rare. The universe, therefore, isn't empty because intelligent life is rare. The universe is empty because surviving intelligent life is rare. And the probability that any given technological civilization survives is probably less than 1%. This creates what researchers call the eternal return of the Fermi Paradox. Even if the universe is full of Earth-like planets, and even if intelligent life emerges frequently, and even if most of those civilizations develop technology, the universe will still appear empty because all those civilizations will be dead. The great silence isn't mysterious. It's the sound of a universe full of dead civilizations. Now here's the part that might keep you awake at night. We are almost certainly living through the exact scenario that killed all the others. We have a biological brain evolved for tribal warfare, but a technological capacity for planetary destruction. We understand exponential growth intellectually, but can't change our behavior based on that understanding. We face cascading existential crisis, but can't coordinate a global response. Every single red flag that indicates a civilization is about to collapse, we're waving. Biologist Martin Rees, Astronomer Royal of the United Kingdom, has estimated that humanity has only a 50% chance of surviving the 21st century. That's his professional assessment based on decades of risk analysis. Philosopher Daniel Kolak has gone further, arguing that extinction within the next 50 years is a meaningful possibility, maybe 10 to 20%. These aren't fringe voices. These are serious, credentialed researchers who have thought deeply about existential risk. And they're probably understating the danger because humans are bad at understanding large-scale risks. Here's what will blow your mind. Every biological intelligence has probably felt the way you're feeling right now if you're taking this seriously. Every civilization has had some proportion of individuals who looked at the situation clearly and felt the weight of impending doom. And most of them were right. Most of them watched their civilization collapse despite knowing it was coming. Because knowing doesn't change behavior. Understanding the risk doesn't prevent the risk. Individual insight can't overcome civilizational momentum. Easter Island had people who must have understood that cutting down the last trees would doom them. But they did it anyway, because the tribal and economic incentives made cutting down trees rational in the short term. Rome had strategic thinkers who understood the empire was overextended, but they couldn't change the military-industrial complex that drove continued expansion. The Soviet Union had economists who understood the system was unsustainable, but they couldn't change the ideological commitment to the system. And we have people who understand that our current trajectory is unsustainable. Climate scientists, biologists, AI researchers, existential risk researchers. They see the problems clearly, but they can't change the civilizational momentum because we're trapped. We're trapped by our evolutionary programming, by our tribal instincts, by our inability to override short-term thinking, by the structural incentives embedded in our institutions. We're trapped in a system that drives toward existential catastrophe, and the system is made of us. We are the system, and we can't escape our own nature. This is why civilizations don't survive, not because they lack intelligence, but because intelligence, when paired with tribal instincts and technological power, becomes a lethal combination. But here's where I need to pivot to something that might save you from despair, because this isn't actually a death sentence, it's a diagnosis. And diagnoses, when caught early enough, can be treated. Here's what researchers are beginning to understand. The critical difference between civilizations that collapse and civilizations that survive isn't luck, it's choice. Specifically, it's the choice to do what I call overriding the default. Humans have default behaviors evolved by millions of years of natural selection. We default to tribal competition. We default to present moment thinking. We default to status seeking and resource accumulation. These defaults made sense in small bands of hunter-gatherers competing for survival. But they're killing us now. However, and this is crucial, humans have the capacity to override defaults. We have conscious awareness. We can see our own tribal instincts and choose not to follow them. We can understand future consequences and choose to sacrifice present benefits for future survival. It's hard. It goes against every instinct we have, but it's possible. And individuals who do this, who override their defaults, become crucial leverage points for civilization survival. Psychologist Mihaly Csikszentmihalyi has documented something called flow states, where humans can become so engaged in an activity that they transcend their normal limitations. Flow states are where peak human performance happens. But there's another state, which I call meta-awareness, the ability to watch your own thoughts, notice your biases, and choose differently. Meta-awareness is trainable. Meditation practitioners develop it. Philosophers develop it. Scientists develop it. Anyone who spends time examining their own thinking patterns can develop it. And in a civilization facing existential risk, meta-awareness is probably the most valuable skill, because meta-awareness allows you to notice that you're being tribal. Meta-awareness allows you to notice that you're being short-term focused. And once you notice, you can choose to think differently. Here's what I want you to understand. You're probably more capable of this than you realize. The fact that you're watching this, that you're engaging with ideas about existential risk and the Fermi Paradox, suggests you already have some capacity for meta-awareness. Most people don't think about these things. Most people default to their tribal instincts, their present-focused behavior, their status seeking. But you're thinking about it. You're considering the possibility that your civilization might collapse. That's already unusual. That's already a form of override. Now, understanding this intellectually isn't enough. You need to translate it into action. And here's where it gets practical. There are specific leverage points for individuals working to increase civilizational survival probability. First, support and engage with existential risk research. Organizations like the Future of Life Institute, the Machine Intelligence Research Institute, the Global Challenges Foundation. These organizations are doing the essential work of understanding existential risks and developing solutions. But they're massively underfunded. A single fighter jet costs more than the entire annual budget of existential risk research globally. If you allocate even a small portion of your resources to supporting this research, you're moving the needle. Second, develop and practice meta-awareness and long-term thinking. Learn to notice your tribal instincts. Learn to delay gratification. Learn to think in terms of 10-year and 100-year timescales rather than quarterly earnings or election cycles. Philosopher David Hume distinguished between matters of fact and matters of opinion. Matters of fact are objective, but matters of opinion, what we value, how we should live, these are what humans actually disagree about. Right now, human civilization is structured around certain values: national sovereignty, short-term economic growth, tribal advantage, individual status. These values are driving us toward extinction. But values can be chosen. Civilizations that survive will be ones where individuals collectively choose different values. They choose long-term thinking over short-term. They choose universal human interest over tribal interest. They choose cooperation over competition on existential matters. You can model these values in your own life. You can choose to cooperate with people outside your tribe. You can choose to think about long-term consequences. You can choose to sacrifice personal advantage for collective survival. This is radical. It goes against evolution. It goes against 10,000 years of tribal civilization. It goes against the incentive structures of modern economics and politics. But it's also the most meaningful thing you could possibly do, because you're literally choosing to be the type of person whose existence increases the probability that human civilization survives. Third, use your skills and knowledge to work on problems that affect long-term survival. If you're a biologist, work on biosafety. If you're a computer scientist, work on AI alignment. If you're an economist, work on sustainable economics. If you're an artist, create works that inspire people to think about long-term consequences. If you're a teacher, educate students about existential risks and long-term thinking. The leverage you have depends on your skills, but everyone has some leverage. Here's what will blow your mind. History is full of individuals who shifted civilizational trajectories through their work. Marie Curie's research on radioactivity led to nuclear energy, which gave humanity the power to destroy itself, but also the power to solve energy problems. Jonas Salk developed the polio vaccine, saving millions of lives. His work showed that a single person could affect the trajectory of civilization. John von Neumann developed game theory and computational theory, foundational ideas for both AI and arms control. His work shaped how we think about strategic problems. Rachel Carson wrote Silent Spring, which launched the environmental movement and changed how humanity thinks about ecological systems. One person's work shifted civilization's priorities. You have the same potential. Not necessarily to change the world single-handedly, but to be the type of person who contributes to civilizational survival. And here's what's crucial. Civilizations that survive are probably ones where a significant fraction of the population is engaged in this kind of thinking. They don't need everyone, but they probably need maybe 10 to 20% of people to have developed meta-awareness and committed to long-term thinking. That seems achievable. That's not asking everyone to be a saint. That's asking 1 in 5 or 1 in 10 people to do the difficult work of overriding their evolutionary defaults. Right now, that percentage is probably closer to 1%, but it could increase. You could be part of that increase. Here's the revelation that reframes everything. The Fermi Paradox isn't just a problem, it's information. It's telling us what civilizations do wrong. It's showing us the pattern of failure. And if we can see the pattern, we can choose differently. Most dead civilizations probably didn't have the advantage we have, the ability to study other dead civilizations through astronomy and fossil records. We know what happens. Most civilizations collapse within a few centuries of developing technology. We can see that pattern. And seeing the pattern, we can choose to break it. That's not guaranteed. The structural incentives driving us toward collapse are powerful, but it's possible. And the probability that we break the pattern depends entirely on how many of us choose to override our defaults. Now here's something even deeper. Maybe the Fermi Paradox isn't actually terrifying. Maybe it's hopeful. Think about it. The silence of the universe is telling us that survival isn't automatic. It's telling us that we have to earn it. Civilizations that make it past the critical period do so through conscious choice, through coordinated action, through overriding their tribal instincts. That means we're not passengers in our own fate. We're not deterministically marching toward extinction. We have agency. We have choice. Every civilization that failed probably had at some point a moment where different choices could have led to different outcomes. We're at that moment right now. And you're reading this because some part of you already knows this. Some part of you has already made the choice to see clearly and think deeply. That choice, multiplied across millions of people, is what determines whether we're another dead civilization or the first few civilizations to break the pattern. Here's the deepest truth. Meaning isn't something you find. It's something you create. And right now, the most meaningful thing any human can do is to choose to be the type of person whose existence increases the probability of human survival. Not out of fear, out of love, out of responsibility to future generations, out of recognition that you're not just an individual, you're a node in a vast network of human consciousness stretching backward and forward through time. I want to leave you with this. We live in a universe of 2 septillion stars. The probability that humanity is alone is vanishingly small. The universe is almost certainly full of life, full of intelligence, probably full of species that reach the point where we are. And almost all of them are dead. That's the terrifying solution to the Fermi Paradox. Not that we're special, but that we're typical. We're at the same critical juncture every civilization reaches. But here's the hope. We can see it. We can understand it. We can make different choices. The cosmic silence isn't a condemnation. It's a teaching. It's the universe telling us what happens when intelligent beings fail to override their evolutionary programming. And it's an invitation to be different, to be the ones who break the pattern, to survive when all the others didn't. You don't have to save the world single-handedly, but you can contribute. You can choose meta-awareness. You can choose long-term thinking. You can choose cooperation. You can choose to use your skills for civilizational benefit. And millions of people making that choice changes everything. We are the rarest thing in the universe. A species that knows it's at the threshold. A species that can see the cliff and choose not to jump. That's not a burden. That's privilege. That's responsibility. That's meaning. So here's my challenge to you. Go back to your life with this knowledge. Notice when you're being tribal. Notice when you're being short-term focused. Notice when you're choosing personal advantage over collective survival. And choose differently. It's harder than defaulting to your instincts. But it's how civilizations survive. The universe is waiting to see if we're the 1%. The ones who make it. The ones who understand the pattern and break it. I genuinely believe we can be that civilization. And I believe that starts with you choosing to think deeply, with you choosing to act with long-term consequences in mind, with you choosing to see yourself not as an isolated individual, but as part of something vast and meaningful. The cosmic silence isn't terrifying. It's an opportunity. Now, go make it count. Thank you for watching. Please subscribe if you haven't already. And in the comments below, tell me, what will you do differently after understanding this? What change will you make in your life based on understanding the critical moment we're in? I read the comments. I want to know how this changes you. And let me know again, where are you watching from? I want to hear from you. We're all in this together.